Hello, and welcome to this series of videos on the TI-30XS calculator. My name is Becky McGuffin, and I'm a math instructor with the Heartland Adult Education Consortium. The goal of this series of videos is to teach you how to get the maximum benefit out of your calculator on test day. When I tutor students, I always begin by asking them how comfortable they are with the calculator. And they almost always reply, "Oh yes, Miss Becky, I know how to use the calculator." But as I work with them, I find they really only knew how to add, subtract, multiply, and divide. I often hear, "I didn't know the calculator would do that," after I show them one of the calculator functions. In this series, we'll go over exponent buttons, scientific notation, fractions, percents, even the store and variable buttons that you'll be able to use for more challenging algebra problems like those you'll find on the GED. If possible, I suggest you have one of the calculators in your hand as we go through these videos. That will allow you to practice each of the keystrokes as we go through different examples. This journey may be long, but I promise it will be rewarding and you will learn something about your calculator before we finish. So let's begin.
First, I want to congratulate you. If you are watching this video, you have made it to the end. This is the final video of this series, and I'm so thankful that you have stuck with it and watched all of the videos to get to this point. This video will be a little different. It's more of a test-taking strategy and how to use guess and check. We will use the calculator for that, but it's more of a test-taking strategy using your common sense and being able to use the answer choices that you're given. So let's look at a few questions to see how we can use guess and check or our common sense to answer questions. So in this first question, it says, Kevin's total payroll deductions are 30% of his earnings. If his deductions add up to $369 for a 2-week period, how much were his earnings for this period? And what many students will do, they see this right here and they will think 30% of 369. But that's not what this is. This question is saying 30% of his earnings equals $369. And so if you take 30% of 369, you're going to get one of these answers down here. 30% of 369, you get answer A, but answer A is not correct. If you think about that, if your deductions are $369, your total pay can't be $110. Your total pay can't be less than your deductions, so we could eliminate answer A even without doing any math. We could also eliminate answer B for the same reason. Your total pay can't be less than your deductions. Now, if I look at the other two answers, one of them seems very unreasonable. I don't know about you, but I don't make $11,000 in 2 weeks. I don't know anybody that does. I could probably eliminate that answer, but let's just look at what we can do to make sure. Since I don't know this, there is a way that we can use the calculator to figure out 30% of something equals what it is, but we have our answer choices here. I know it has to be one of these two. Let's take these two answers and multiply times 30% and see which one gives us the correct answer of $369. $1,230 times 30%. Well, there it is. 370. That says 378. Oh, I did 1260 instead of 1230. Oops. All right, clear. 1230 times 30%, 369. So I know that's my right answer. If I do this other one, $11,070 times 30%, we get $3,000. But like I said before, I could probably eliminate that just based on common sense. But on the GED, You might be able to eliminate a couple of answers based on common sense, but probably you're not going to be able to eliminate them all. But eliminate what you can for common sense purposes, and then use what you know to figure out which one would give you the correct answer. Let's look at some more examples using common sense and our guess and check strategy. So Neva's car is now worth $12,000. This is 60% of what she paid for it. How much did she pay for the car? So once again, a lot of people will think 60% of 12,000. That's not what this is. 60% of the cost of her car equals what the car's value is now. So when I look at my answer choices, is there something I can eliminate? Well, I should be able to eliminate answer choice A, because if her car is worth $12,000 now, it wasn't worth less than that when she paid for it. It's got to be worth more than that when she paid for it to be worth $12,000 now. So we're going to eliminate answer choice A. And then we're going to use our guess and check strategy to figure out which one of these answers, if I multiply them times 60%, which one will give me the $12,000 value now. So let's try 18,000 times 60%. $10,000, not right. Okay, 19,200 times 60%. 11,520. Getting closer, but not there. Hopefully, 20,000 times 60%, $12,000. There's our correct answer. So eliminate answers that you can, and then use your calculator to guess and check the others. Okay. Some other times on the GED, they have you work backwards. And a lot of times this messes with students. They can't quite figure out how to do this. They do this with geometry questions. They do it with average questions. And what a lot of students really want to do is add all the numbers and divide by 5. Many students know how to find the average, but when they're asked to work backwards or to find a missing number or something along those lines, they really struggle with that. So if we look at Goofy's golf average, after 6 rounds, his average was 81. These are the scores for his first 5 rounds. His scores were 78, 86, 82, and 80. 78, 86, 82, 81, and 82. What was his score on the 6th round? So what this is saying is there are 6 scores. 78, 86, 82, 81, 82, and something. That when I divide that by 6, I will get an average of 81. So we want to take these 4 numbers and put them in this spot and see which one gives me an answer of 81. As I said, some students will want to just average these 5 numbers, or some will say, oh, well, he has to get an 81. But that's not always the case. So what we're going to do, we're going to add these 5 numbers and get a sum of those 5. So 78, 86, 82, 81, and 82. So far he has 409 points in his golf game. All that sum is 409. So we're going to take 409 and add it to each one of these. We may not have to add it to each one of these if we find our answer is A. And then once we have that answer, we're going to divide it by 6 and see which one gives me the answer of an 81 average that we want. So let's go with answer choice 1 first. 71 for that score plus 409 that we've already scored gives me 480. And when I divide that by 6, I get an average of 80. Well, that's close, but I'm wanting an average of 81. So A is not right. So we can do 83. So 83 plus the 409 I've already scored gives me 492. Divide that by 6, and we get an average of 82. Well, that's too much, so it's not 83. So let's try 77. 77 plus the 409 we've already scored is 486. Divided by 6 gives me my average of 81. Now, another way you can do it, and I show this to students, but a lot of them, when they get in the test and they're kind of rushed, sometimes they have a hard time remembering. You can take 81 and multiply by 6. I want an average of 81, and I'm going to play 6 games. 81 times 6, and then subtract that 409 points that we've already gotten in the first 5 rounds of golf, and that will also give us the score of a 77 that we have to get. But if you struggle with working backwards or thinking through that process, this can also get you to the correct answer if you have multiple choice answers. If you don't have multiple choice answers, you're going to have to remember multiply by how many numbers there are and subtract the ones that you already know. I mentioned that they do this some on geometry questions. Here's a geometry question where we have to work backwards. They tell me the volume. The popcorn tub holds 1,850 inches cubed. A lot of students know how to use the formula sheet and work forward to find volume, but they struggle when they're given the volume and asked to work backwards to find a radius or diameter or a missing dimension. So we're going to use our answers for this. The first thing we would have to do is look at the formula sheet and find the formula for the volume of our popcorn tub, which is a cylinder. So on the formula sheet, volume equals pi r squared h. And so what we're going to do, we're going to take each of these. What is the radius? So each one of these numbers represents a radius. We know pi always, and they have told us the height is 12. So what we're going to do, we're going to take each of these numbers, put it in our formula, and see which one gives me the closest number to 1,850. So on this first one, 3.14 times 5 squared times 12. On this one, 3.14 times 6 squared times 12. 3.14 times 7 squared times 12. And 3.14 times 8 squared times 12. Now, we might not have to enter all 4 of them because we might find the answer early. But that's taking each of these answers, putting them in the formula. Now we're going to put them in our calculator. 3.14 times 5 squared times 12. I got 942. That's not very close at all. Okay, 3.14 times 6 squared times 12. I got 1356.48. We're getting closer, but not there. Let's look at 7. 3.14 times 7 squared times 12. 1846. Well, it's not 1850, but it's pretty darn close. I bet this last one is going to be too high. 3.14 times 8 squared times 12. 2411. Which one is closest? This one. And the reason we probably didn't get the exact answer is because this right here. Round your answer to the nearest whole number. So the actual radius is probably not the whole number 7. And that's why we didn't get the exact number. If you didn't have multiple choice answers, you would want to take this answer of 1850. Okay, we're going to use this formula up here. 1850 has to equal 3.14 times my radius squared times my height. And then using algebra, we would take this 1850, divide by 3.14, and divide by 3.14. Then we'll take that answer and divide by 12. Divide by 12 to get rid of that. And then what we're left with is the radius squared. 1850 divided by pi divided by 12 gives me 49.09. Now that's not the radius, that's the radius squared. So to find the radius, we have to take the square root of that. Square root of 49, very, very close to 7, okay? Approximately 7. So that's how you would do it if you didn't have multiple choice answers to work from. So you can use if you have multiple choice answers, use the formula and work forward. If you don't have multiple choice answers, you have to use the formula to work backwards and solve the equation to figure out what the radius is equal to. Okay, let's look at another one. So this one is a frequent kind of thing that you can use inequalities. You can write an inequality to figure it out, and I'll show you how to do that. But we can also use our guess and check. So Max is going to order pizzas from Pie Town for a Super Bowl party. At Pie Town, pizzas cost $14 each, and they charge a $12 delivery fee. How many pizzas can Max order for $80? So let's think about this, and I have these answer choices. Okay, so if I think about how many pizzas we can order, and each one is 14, $3 times $14 per pizza plus a $12 fee. I can do that quick little math. 3 times 14 plus 12 tells me that's going to be $54. Well, that's okay. My budget's $80, so I'm okay with that. Let's try 4 times $14 for pizza plus a $12 delivery fee. Gives me $68. Okay, still got quite a cushion there. Let's go to 5 times $14 plus 12. 5 times 14 plus 12 gives me $82. Oops, now I'm over my budget. So how many pizzas can we buy? 4. We may be able to throw in an order of breadsticks or something, but 5 would put us over the budget. If you didn't have multiple choice questions, here's how we can tackle this. You can take my budget, subtract my $12 one-time delivery fee. Okay, that leaves me $68. 80 minus 12, $68. Now I'm going to divide that by 14 to figure out how many pizzas I can get. And I get 4.85. But when students do it this way, a lot of times they forget, I round up. 4.85, well, you would round up to 5. But we already know if I buy 5 pizzas, I have gone over budget. This kind of question you cannot round up, because when you round up, that puts you over the budget. So we would just have 4 pizzas, but we'd have some leftover money that we didn't spend. If they ask you to write an inequality for this, they didn't ask you to figure out how many pizzas, but they said, which inequality could you use? You always want to be less than or equal to your budget. We want the cost of our pizzas, $14 times our pizzas, plus our delivery fee, to be less than or equal $80. And what they'll do, they'll switch these numbers around. They'll do this. Okay. Well, we're not charging $12 per pizza. The $12 doesn't get multiplied by a variable because that's a one-time fee. So we can eliminate that one. The other thing they'll do, they'll flip this sign and do 14p plus 12 is greater than or equal to $80. Well, in a budget question, you never want this side of the equation to be greater than your budgeted amount. That puts you over your budget. Okay, what you're looking for when you have to write an inequality is the per item, $14 per pizza. That's the one that gets multiplied. Plus the $12 one-time fee has to be less than or equal to whatever your budgeted amount is. But if you aren't good at writing the inequality, you can use the guess and check strategy to figure out which one of these will get you It's kind of like The Price is Right, the highest amount without going over your cost of $80. So that's how you can tackle those questions using guess and check. Okay, here's another one. Andy is 2/3 the age of his brother Arthur. Andy's sister Amelia is 6 years younger than Arthur. Together their ages total 74. How old is Arthur? Well, you could write algebraic expressions for this and solve it, but it's much easier just to use guess and check. So let's play with our numbers. These answers, this is the first part of it. You have to figure out what the answers represent. The answers represent Arthur's age. Okay, so we're going to make 3 columns. We got an Arthur column, an Andy column, and an Amelia column. And let's look at what they tell us. Andy is 2/3 the age of his brother Arthur. So I need 2/3 of Arthur. So we can use our calculator if you're not great with fractions. 2/3 times 18. That means Andy would be 12. If we do 2/3 of 24, 2/3 of 24, that would be 16. If we do 2/3 of 30, that would be 20. And if I do 2/3 of 36, that would be 24. So if these are Arthur's ages, these have to be Andy's ages. Now let's go back and see what they tell us about Amelia. Amelia is 6 years younger than Arthur. So we don't have to multiply times a fraction. We just have to take Arthur's age and subtract 6. So this is, Andy is 2/3 times Arthur. Amelia is Arthur minus 6. 6 years younger than Arthur. 18 minus 6 is 12. 24 minus 6 is 18. 30 minus 6 is 24. And 36 minus 6 is 30. So now we have how old Andy and Amelia would be if this is Arthur's age. Now to solve the problem, the total age has to be 24. We're going to add these 3 numbers and see which one gives me 74. 18 plus 12 plus 12 gives me 42. Nope, A's not right. B, 24 plus 16 plus 18. That is 58. Also, not enough. C, 30 plus 20 plus 24. 74. That's my total age I'm going for. Arthur must be 30. Okay. If you were to write an algebraic equation, we have to use these things down here. We would have to say Arthur's age plus 2/3 times Arthur's age for Andy plus Arthur's age minus 6 for Amelia, and all of that would have to equal 74. And then we'd have to solve the problem algebraically, which you can do it that way as well. But a lot of times people struggle with writing these equations, and sometimes guess and check is just the easier way to go if you are given multiple choice answers. I think I have 1 or 2 more. Oh, the children of the Hayes family play lots of sports and have a large collection of balls in the garage. There are half as many basketballs as soccer balls. There are 9 more tennis balls than soccer balls. They counted 39 total of the 3 kinds of balls. How many soccer balls does the family have? So once again, this is the same kind of question as we had with Arthur and Amelia and Andy, but now we have a collection of balls. They'll do collections of marbles and different things. But what we have to do first is look and see what our answers represent. Okay, our answers represent the number of soccer balls. That's what these numbers represent. We're going to make 3 columns. We have soccer balls, we have basketballs, and we have tennis balls. So let's look at what the question tells us. There are half as many basketballs as soccer balls. So half as many, half soccer. All right, if they have 6 soccer balls, they have 3 basketballs. If they have 9 soccer balls, they have 4.5 basketballs. Can you have half a basketball? No. I can eliminate that one and not even go any further. That's a common sense kind of thing. I can't have half a soccer ball, half a basketball. So throw that answer out. 12. Half of 12, they would have 6 basketballs. Half of 18, they would have 9 basketballs. So now look at what they tell us about our tennis balls. 9 more tennis balls than soccer balls. So now we're going to do our soccer plus 9. 6 plus 9 is 15 tennis balls. 12 plus 9 is 21 tennis balls. 18 plus 9, 27 tennis balls. And now the next thing we need to do is add our 3 numbers and figure out which one gives us the total of 39. 6 plus 3 plus 15, 24. Okay, 12 plus 6 plus 21, 39. There's our answer right there. 12 soccer balls, 6 basketballs, 21 tennis balls. If you had to write an equation, soccer balls plus half soccer plus 9 would have to equal 39 tennis balls. And if we solve that equation, this is 1, 2.5, I'm going to use 2.5 soccer plus 9 equals 39. Subtract 9 from both sides. 2.5 soccer equals 30. And if I take 30 and divide by 2.5, 12 is the answer to the number of soccer balls. So if you had to solve it algebraically and you know how to write equations and solve equations, that's how you would do that problem. And that's the last of my example problems to go through with you. There are lots and lots and lots of practice questions, 2 pages, a 2-page worksheet to practice using your answer choices to figure out. Some of them are inequalities, some of them are volume or geometry questions, some of them are working backwards to find the average questions. So there's lots of variety of questions on that worksheet, and I encourage you to try to work your way through some of those questions. Once again, I'm so thrilled that you have made it to the end of this series, and I really hope that you have learned some things about your calculator that will help you on your test. Now it's time to practice. I encourage you to get to know your calculator, get very comfortable with it, and learn as many tips and tricks as you can for your calculator to help you on test day.